Hi everyone, welcome back to Statistics and Data Analysis. Today we will talk about hypothesis testing. Okay, let's start. So, basically when researchers, or more specifically scientists, when they want to do research about something that they don't know, what's the typical process? It's first to observe some phenomena, and according to what we observe, we make some hypotheses. Okay, and then we would test the hypothesis through some experiments. Those scientists, they would do some experiments and try to confirm or reject those hypotheses, and then finally make some conclusions. Even though that we are in the business world, still, when we want to do some research, we typically follow the same way. And for statistics, there is one thing called hypothesis testing that is most likely repeating what those scientists do. Okay? It's one of the most important technique of statistical inference, and that technique is used for proving things. So we're going to face an uncertain thing. There is something we don't know. We're going to make some hypotheses about those unknowns, and then we try to follow a procedure to prove or disprove what we believe. Okay? And again, that relies on some observations. So we need to have some sample. And with sample, we need to have sampling distributions so that we can do inferences. Okay, so today in the next lecture, we will introduce hypothesis testing to you. So in this video, I'm going to talk about the basic ideas, and the next video will also do the same thing. Then we have our examples, so that we can illustrate the idea with you to you with some examples. And finally, we will talk about one important concept called Pvalue. When we are doing business or when we are doing social science, we always ask a lot of questions. For example, if I am running a company, I need to know how my workers are loyal to me. And I probably want to ask, if a worker is older, then is it more likely for he or she to be loyal to me? Well, that's some questions I want to ask. Or when we hire a new CEO, I may need to confirm or verify whether this new CEO really increase our profit. Okay, we want to know this. We probably want to know if we're going to have an election, is one candidate preferred by more than 50% voters? Because, again, that may affect our decisions about a lot of things. When we are running a fast food restaurant, we may need to know whether teenagers eat more fast food in general than adults. Okay, we need to understand our customers. Or when we are doing manufacturing, we may need to know whether the quality of our products is stable enough. And there are all kinds of questions to ask in all kinds of situations, and that questions typically has one thing involved. That's an unknown parameter. And there is something we don't know for the population. So how may we answer these questions? Basically, we want to know something about our population. So we're going to first make a hypothesis, and then collect random samples, and then use statistical methods to test our hypothesis. Okay, that's the procedure that we're going to teach you how to do that. We're going to first have an hypothesis. We assume something to be true, and then we collect data. With some statistical procedure, we test whether our assumption is true. Okay, that's our plan. So let's formally introduce statistical hypothesis to you. A statistical hypothesis is a formal way, in our statistics world, is a formal way of stating a hypothesis. Typically, it is represented as a mathematical description of a parameter to test. It contains two parts. Okay, a hypothesis has two parts, or you can say is constructed with two hypotheses. So one is called the null hypothesis, the other one is called the alternative hypothesis, and we will typically write them as H0 and HA or H1 respectively. Okay, so what are them? There is one thing called alternative hypothesis, which is the thing that we want or we need to prove. Or say it in another way, this would be a statement that we're going to claim only when we have a very strong evidence of that. Okay, so if we see something that provides a strong evidence to us, then we conclude that the alternative hypothesis is true. On the other hand, the null hypothesis is actually our default position. Before we collect any data, before we see anything, we would assume that the null hypothesis is correct. So that's our basic idea, that's our default position about the unknown. And then we would collect some sample data. Then, when we assume that the null hypothesis is true, it is quite unlikely to see our observed results, then we would have a strong confidence saying that the null hypothesis is wrong. Okay, one very naive example is that we're going to say that, okay, there is a dice in front of me and I want to know whether it is fair. Okay, if it is fair, then we expect to see most of the values distributed uniformly among 1, 2, 3, 4, 5, and 6. Okay, but if we roll the dice for 10 million times and always we see 1, it's possible for a fair dice to give us that outcome, but it's so impossible, right? Then we have a very strong idea about that null hypothesis is wrong. And then we would say, okay, I think the dice is unfair. So in that particular example, our H0 would be the dice is fair. Okay? Because before we do any experiments or collect any data, we have a default position, which is the dice is fair. Under that assumption, we roll the dice, and we found it's so impossible for that to happen. Then we conclude that our HA, which is the dice, is unfair. Okay, we would conclude that the dice is unfair because we have that strong evidence. So that's the basic idea. So let's use another example to really give you a formal description. Suppose in our factory, we produce packs of candies whose average weight should be 1 kilogram. So each bag should contain 1 kilogram of candies. One day, a customer told us that he got a pack and that pack has only 900 grams, which means he feels that this bag is too light. He should get more candies with the same price, but he didn't, so he complains. Okay, so that's an important thing. We need to know whether this is just a very rare event or our production process is actually out of control. In any case, we need to somehow reimburse the customer, okay? Because that is too light. If that's true, then that's too light. We need to return some money to the customer. That's one thing. Another thing is we need to know whether this happens just in case, or just with a very low probability, or this is actually something that systematically occurs. We need to know whether our machines or the production process is still fine, so that our average weight is 1 kilogram. Okay, there are actually a lot of things to test for a rigorous quality control process. We need to also know for example, standard deviation. Okay, standard deviation should be small enough so that the process is really stable. But here, let's just focus on the average weight. Okay, at least the average weight should be what we want. So, how do we do that? Suppose we believe that the system is out of control. We're going to do something, right? We need to shut down the machine and spend, for example, 2 days to do inspection and maintenance. This is going to cost us a lot. So now it's time to make a decision. Either we shut down and do the maintenance and it pays a lot, or we keep going without a maintenance. So doing this decision is hard. We need to first collect some data to support us about whether we need to do that. So we should not just believe that our system is out of control because of one complaint. Okay, one complaint is not so strong enough. We probably should collect more data and then try to convince ourselves that the machine is really having some problem. Okay, so what should we do? We first state a hypothesis. Our production system is under control. Okay, before we really get any information, before we really get any data, we should assume that the system is fine. Okay, only after we get some signal, then we assume that it's out of control. But before anything, before we see anything, we should assume that it's under control. And then we should ask, well, is there a strong evidence showing that the hypothesis is wrong? Okay, so we're going to collect data and then try to ask whether I can reject the original hypothesis. Then we would shut down the machine only if we can reject the original hypothesis, only if we can prove that the system is indeed out of control. Then the statistical hypothesis is written in this way. Okay, always we would write down H0 and H1 or HA, and we put them together. In this example, suppose mu is the average weight. Then our default assumption, default hypothesis, is the null hypothesis that the system is under control. Okay, mu is 1 kilogram, mu is 1. Or we say HA is the other way, so mu is not 1. We want to see whether after we collect some sample data, whether we have found an evidence showing that H0 is wrong. Okay, we want to first have an assumption and then collect data and then look into the data and see if we have a strong evidence to claim that H0 is wrong. In that case, we would support the statement in HA, the process is out of control, and then do some inspections and so on. If on the other hand, we do not get a strong evidence, then we will still stay with our default hypothesis and keep doing the same thing. Okay, so that's the first part of the introduction. Thank you.